guys, welcome to math class. (4.1d) Volume and displacement. How are volume and water displacement connected? You can find the volume of a solid using displacement of water. Volume does not only apply to something in the shape of a cuboid. A stone also has volume. When we find the volume of a stone as 10 centimeters cubed, for example, that means if the stone were like clay and that we could press it into a cuboid, it would occupy the same space as 10 cubic centimeters. But what is water displacement? Water displacement happens when an object is submerged in a fluid and the fluid is pushed out of the way, or displaced, to make room for the object. The amount of water displaced is directly related to the volume of the object. How can we find the volume of a stone? If you were to put a stone into water, it will displace an amount of water equal to its volume. The displaced water can be measured by pouring it into a calibrated container, such as a graduated cylinder. The volume of the water displaced is the same as the volume of the stone. Example 1, textbook, page 57, number 6. A rectangular tank, 35 centimeters long and 25 centimeters wide, contained some water and a stone. The height of the water level was 10 centimeters. When the stone was taken out, the water level dropped to 8 centimeters. Find the volume of the stone. For this problem, we want to find the volume of our stone using the methods of water displacement. The container that our stone is in has a length of 35 centimeters, a width of 25 centimeters, and we're not sure what the height of the container is, but that's not what's important. What's important is the height of the water. So when the stone is in the water, the height is 10 centimeters. When the stone is taken out of the tank, then the water level drops because it's not taking up that space inside of the tank anymore. We want to find the volume of the water that is displaced by the stone. We're going to find this by using the difference in how much that water level dropped. We know the length is 35 centimeters and the width is 25 centimeters. So we can go ahead and plug these numbers into our formula. Again, the formula we're going to use is length times width times height. So our length is 35 centimeters times our width, which is 25 centimeters. And we're going to multiply this by how much that height changed. So if it started at 10 centimeters high, and then it dropped down to 8 centimeters, the difference is 2 centimeters. Now we can go ahead and multiply this out. 35 centimeters times 25 centimeters. I'm going to go ahead and have my work off to the side. So we have 35 times 25. 5 times 5 is 25. 3 times 5 is 15 with our additional 2, which is 17. Then we're going to cross off this place value since it's already been accounted for. 5 times 2 is 10. Bring up our 1 right here. And 3 times 2 is 6, with 1 more is 7. So we don't have too much room down there, but we can go ahead and bring that answer over here. So 5 plus nothing is 5. 7 plus 0 is 7, and 1 plus 7 is 8. Now we have 875 times 2. I want you to see if you can do this mentally. The problem again is 875 times 2. Your answer should be 1,750. And lastly, we have our units, which is centimeters times centimeters times centimeters, which is centimeters cubed. So our stone takes up 1,750 cubic centimeters worth of space.
Example 2, textbook page 57, number 7. A rectangular tank measuring 50 centimeters by 40 centimeters by 40 centimeters is half filled with water. When 3 metal cubes of edge 10 centimeters are placed in the tank, the water level rises. Find the height of the new water level.
For this example, we are going to be looking for how much the water height increased when we added these 3 cubes into this tank. We're going to use this formula right here. Height equals volume divided by area. So we are going to find the height that we're looking for is going to be how much it increases. The volume we're going to use is the 3 cubes. This is because this is how much volume we're adding to the tank. Just like we want to see how much height is added to that water level. And we're going to divide the volume of those 3 cubes by the area. That is the area of the base of the tank. So let's go ahead and solve this. Height equals volume. Let's find the volume of our cubes. Our cubes have edge of 10 centimeters. That means that the length, width, and height of our cube is 10 centimeters. To find the volume of each of our cubes, we are going to multiply length by width by height. So we have 10 times 10 times 10. And we know that they're all going to be in centimeters. 10 times 10 is 100. 100 times 10 is 1,000. And we know our unit is centimeters times centimeters times centimeters, which is centimeters cubed. So I'm going to add that right over there just so we don't forget. So the volume of each of our cubes is 1,000 centimeters cubed. But since we have 3 of them, we are going to need to multiply this volume by 3. What is 1,000 times 3? 3,000. And we know our unit is centimeters cubed. So where we had volume in our formula, we just plugged in our 3,000 centimeters cubed from our 3 cubes. We'll divide this by the area of the base. So our base is 50 centimeters by 40 centimeters. We're going to multiply those 2 numbers together. So we have 50 centimeters times our 40 centimeters. I'm going to bring down our height equals 3,000 centimeters cubed, and now we can multiply out our area. So 50 times 40. One way you can solve this mentally is think, what is 50 times 4? That is 200. Times 10 is 2,000, and our unit is centimeters cubed. So the height, that's how much it increases in height, is 3,000 centimeters cubed divided by 2,000 centimeters. Oh, that's not supposed to be cubed. That's squared. Sorry about that. 3,000 centimeters cubed divided by 2,000 centimeters squared. We can cancel out 1, 0, 2 zeros, 3 zeros, and if we have centimeters squared and centimeters cubed, we can actually cancel out our squared and our cubed, but our cubed has 1 more centimeters than our squared did, so we're just gonna cancel out our cubed, and that leaves us with just centimeters. So we have 3 over 2 centimeters. How many centimeters is 3 over 2? We can simplify this to 1.5 centimeters. So we know the height of the water increased by 1.5 centimeters. But what was the water height originally? We know that the height of the entire container is 40 centimeters, and the problem originally said that our tank was half filled. So what would half of 40 centimeters be? 20 centimeters. And if it increased by 1.5 centimeters, what is 20 centimeters plus 1.5 centimeters? 21.5 centimeters. The height of the water after we added the 3 cubes is 21.5 centimeters.